contribute to. Okay, so I have this assembly here, and in order to work on the redesign of this particular arm, the green arm here, easy way to start that is by clicking on the part and doing right mouse click and then choosing the open part command. So I'm saying that open this part file. So they will open this part file separately, and I believe that that's doing it, and here it is, right? So this is the shape, and what you need to do is this. You can redesign the part in Solidworks, no problem. That's always an option. But because one, we are very versed with other modeling software like Maya or even Rhino or whatever. And two, it's very time consuming sometimes to do new design in SolidWorks. So this is what I recommend. This is my approach of doing this. First thing you should do is you should identify the critical surfaces that are contacting other parts in the assembly. So in this case, if you examine here, this front portion here, see the yellow part here, that's another part, right? And this green part. So inside here are the combination of surfaces that are contacting, touching, that is necessary for assembly. So let me show you one quick key. If you press the tab key, if you go over any part with your cursor and press the tab key, you can make that part invisible so you can see what is going on here. So some of these surfaces here, this one and this one and this one, these are the really critical and important surfaces that are mechanically touching, and they need to be correct for the new part design. So you can say that even for the new design of this arm, these surfaces have to be pretty much the same, if not, mostly similar, right? So you can say, hey, I need to have this width cylinder and another cylinder inside in order to have this part successfully fitting correctly. So and then same is true for this end. Press tab, make this part invisible, and these surfaces here are the same story. Minimum of these three surfaces, and maybe these two, these also, right, are critical, and they need to be the same for the new arm design. Is it making sense so far? Okay, some nod, and don't feel afraid to say no if you disagree. Maybe there's a reason for that. So let me do Shift Tab to bring back the part, to make it bring it back from being invisible. So that's what I will do. I will go to the part file, and I will make duplicates of those critical surfaces. And this is how you do it. You can simply click to select those surfaces, shift click, and shift click, and maybe I will shift click, and maybe also I will include this one. So I selected those surfaces, and then I will also select these surfaces here. So shift click, shift click, shift click, shift click, and maybe also this one, just as a reference. It's okay for you to shift click select more than necessary, because you can always delete what's not necessary. So what I've selected here are the critical surfaces that my new design of this robot arm should be respecting. So my new design of this arm should have these surfaces in place as well. So I will do the command to insert feature offset. Offset is basically the same as copying. So if you want to duplicate surfaces off of solid forms, you can use offset. But here, the distance from this original is 0 amount. So that's how you do duplication of surfaces, is offset with 0 amount is how you duplicate surfaces in SolidWorks. So complete. And here, what I have is, I have the original arm here, but I have the family group of surfaces that are duplicated off of it. And under the surface bodies, there are two sets of bodies. One is over here, and the other is over here. In fact, let me hide the entire solid body. Let me press tab, and you will see that there are two bodies of surfaces. One is this one here, and then the other is this one. Okay, so these are the surfaces that I can actually uh, export to other CAD software or 3D modeling software to work work with. So this is what I will do. Even though it's made invisible, this solid form is still there. So I will delete the solid form. So you can just say that you say bus, or one of these is actually so delete, say body, delete. Yes. So there is a delete or keep body. So this is the command you use. And I will say delete bodies, and it's this large one. And if I do that, this part is no longer here. Now, because SolidWorks is parametric and history based, you can always take this feature manager and rewind so that you get these parts back. You can reverse the time until the point where, basically you go. This is a time machine. This is before, after, and then most recent. Okay. So currently at this state here, I only have the surfaces, and then you don't have anything listed under solid body. You see that? Because I chose the delete body function. But if I rewind one step, there is a list of one solid body under solid body list. Okay? So that is the difference between before or after the delete body command. Okay? So don't be confused about that. This is nothing more than just a time machine that you're able to rewind or go forward in time or backward in time. Okay. So now what I will do is I will export. I will save. I'm sorry, not export. It's save as, and save as. You need to do save as copy and open, because you don't want to modify the original one. I want to just save this a duplicate version of this. So save as copy, and you say KUKA robot, and this is KUKA robot arm for old. Well, I'm gonna say this is new, and then this is version. Well, I'm gonna say just A for I'm gonna say A, B, C for like variety. So now I'm not going to choose a SolidWorks part file, but I'm going to choose like IGES file. IGES file is a NURBS surface only. So that IGES file will be importable. It will be you can import into other software like Alias or Maya or Rhino. Okay, and you don't need to do options, but I will show you. Under options, you have like different types of software like Mastercam. These CAM software has most number of vertex points. Other ones like standard, like they have fewer number of vertex points, and sometimes trimmed surfaces come out wrong. So that's why I had it under Mastercam, I believe. Okay, so but you can choose simpler ones if you like. You have to experiment sometimes choosing the different flavor to get more success. Okay. So now this is named KUKA robot arm for new A. So that is descriptive enough for me. So I will save this. And once that is successfully exported, I think that it opened this new one. You can see that the KUKA robot arm new A is opened into a new SolidWorks file. But it should also have saved the IGES file version. Okay, so let me show you that. Let's see, lectures. Oh yes, I'm in week 13 under SolidWorks examples, or maybe I think that I might be in the KUKA robot Maya. Yeah, I think I'm under this folder. So if I do, so robot arm forms v3, maybe it didn't save it. ARM3 new form. That's has a very old date on it. Oh, you know what? I think I might have saved it in the wrong folder. So let me just resave this actually. Copy. Okay. And since I have this yeah, since I have this here, well, you know what? Let me be consistent and go back to this one and re-export from here. Yeah, I don't want to confuse you any more than necessary. So here, let me do once again, file, save as, and save as copy and continue. I should have chosen this one because this requires that it opens the copy version as a SolidWorks par file. So I should have chosen this one. Yeah, sorry about that. I think that yes, I saved it at the wrong location of the folder. So let me erase this and paste the correct file location. And here, this one, I will choose the IGES file and unfold, and this I will name it new, and then A. Okay, so that's descriptive enough for me to know that this is a updated version, and yeah, so save this, and yeah, let me actually don't save. Let me, and then at this point, I'm ready to import that IGES file in any other software and then do a new design. And I'm going to do that in Maya, actually. You can use pretty much any software that can import IGES file, and then you feel comfortable and fast and productive in. But in this case, I will choose Maya because it's it's very sculptural, and it's very easy to like bang out like quick forms that are interesting and potentially useful. So that's what I will do. And I believe that yeah, so this is yeah, this is a Maya project folder already. I have all these necessary folders, including the scenes folder and also the OBJ IGES file folder where these files are here. So let me first to set project. Oh, let me yes wait until the software is fully loaded. Give me 1 second. Okay. How is it so far? Am I going too fast or too slow? Is it if I go faster, the recorded video will be shorter, but you might get confused the first time around. I know, like I don't know. Do you what is the threshold for you to watch any video? 10 minutes or 20 minutes or 1 minute? I don't know. 1 hour video is way too long for you, right? It's like wow, YouTube 1 hour video. That's crazy, right? So let me see. Set project, and yeah. So here I will choose the Kuka Robot Maya, that project set, and I don't know if there's any Maya scene file. Oh, it looks like there is, but I'm not going to depend on this one. Maybe I'll open these later to show the finished version, but I'll create a new file. Okay. So what I will do is I will import the exported IGES file. You can see that in this folder, Kuka Robot Arm 4 new A IGES file is here. So I believe you can drag this into this, no problem. Or you can say file import. Either way is fine. Visually, like people are like, oh yeah, I'm just gonna drag this into it. I don't think there is any problem with doing that. You can see that the location of this is, it's away from the origin because that's how the part was designed. If you notice in SolidWorks, that's the story. There is the origin here. This is the origin over here, and it's somewhere up here. So it kept it consistent in the same way. So Maya keeps the same XYZ position and size. So there are these number of surfaces. There are multiple of them. And you might say, well, I might, I might have selected only maybe like 6, 7, 8 surfaces in SolidWorks. How come so many more than that? Well, the reason is that a lot of these things, like the revolve surfaces, it has to split it into 2 separate ones. Okay, so just keep that in mind, and it's a requirement. Mathematically, it has to be 4-sided boundary. So anything that is revolved, it will split it into a minimum of 2 pieces, and sometimes 4. So depending on the situation. So that is very normal and regular. But here, let me just do some grouping. Let's select this, group this into one, group this into one. If you're very meticulous and organized, I encourage you to name these also, okay? But here, for the time being, I'm just going to assign it to a layer, and I'm going to say these are the joint reference surfaces. Something that is descriptive and helps you organize. Okay, so you can have that visible or just a template or reference only, whatever you need to. Okay, and in this case, I'm going to do a template because it's visible. I can depend on it, and I can design with this. Actually, you know what? I'm going to do a reference layer like this. Okay, and because with this information, I can design any kind of reasonable form, keeping in mind that the critical ends are being respected. Okay, So it's usually nothing more than just working with something like a cube, okay, and just sculpting something out. So you can say, hey, I want to work with a cube, and I want to make it big and long, and maybe like this, and maybe I will move it to the appropriate location, okay, and something like this. So if you enjoy sculptural visual modeling, you will enjoy this process very much. On the other hand, if you are like an engineering freak, or I should say, very meticulous and really into mechanical preciseness, you might feel a little bit uneasy at first. But that's okay. Everybody has different styles and different, propensities. But here, the important thing is that you can work in very sculptural, visual way. So I think that I forget exactly. Let's see. So this one here. Let me just rewind this. Let's see. So if I can meet this demand, I see. So I think it's okay for me to I'm switching back and forth between Solidworks, how the original part looked like, okay, and then how that fits in the assembly, so that in context, how it. So if I come, let's see, all the way to here, so I think that yeah, if I'm generally in this area, I think it's fine. Okay, okay, okay. So that'll be my bottom critical. And then what about this part here? If I examine this part, there's not too many like extra structure. If this thing swings like this, and I don't want this to hit my thing, right? So there's some extra things here. So if I generally stay with the form that was kind of like similar to original, I don't think I will get into too much trouble, right? So okay, so that's good for me to examine. So I think that on the front part, I will scale to something like this, but I will move it, something like that. Okay, and then I will modify the 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 positions of vertices to design update here. Okay, so let's examine the positions and size. It looks like this, some of these numbers can be rounded off to something more clean. Maybe, yeah, maybe 56 was better, but it's not really critical that you get like really amazing numbers. But I personally enjoy like just having nice numbers that are a little bit more cleaner. Okay, I'll be doing sculptural changes to this anyway. So at this point, I say, all right, in order to do some sculptural modeling, I can increase some number of sections in certain directions. Maybe I can do something like this. Maybe, yeah, that's kind of reasonable, right? So generally speaking, if you have square proportions for these faces, it's not a bad idea. So I want to do like general like a curvature, some like graceful curves. So that's why I'm making this more sporadic, not so dense. So let me see if I can do that. So I can do number 3, right? To make it more, you know. So let's see if I can do edges. Maybe do a double click, or maybe I should do click and shift double click. So that lets me select a lot of these, right? So I can do some sculpting here, click, shift, double click, and that lets me do something like this. And I want to taper this front end here, so maybe it involves select some faces, shift, and then I will do maybe a little bit of movement. Well, actually, maybe I should do these faces too. So oh, what am I doing? I wanted to do soft selection. Remember soft selection? This one, right? That's what I wanted to do. I forgot that I didn't turn that on. So something like that. Okay. Maybe I'll do scale to, yeah. So it's kind of like similar to what was there before, but not so, not like circular per se. Okay. So something like that. And you can take as much time as you want, or you can be as fast as you want. So let's see. Let's examine the back area. So in the original, let's see how much extra I had back here. So it seems like there were some like things going on in the back. It is probably connected with other mechanical things. But it seems like I got like certain amount of room that I got to play with. So maybe for this, I'll leave a little bit of overhang and just do something interesting, right? So maybe I'll taper it a little bit. Yeah, so and then maybe this direction also. Okay, so a little more streamlined. Streamlining in a lot of cases can be good. You know, reduces visual clutter as well as physical clutter. And so let's say you're kind of okay so far, but let me do one more last thing. I want to keep a little bit of flatness here that is kind of like close to approaching the circle. So in addition to what's going on here, let me just do an extrusion. So if I'm here and then if I extrude these faces, I'll get something. Oh, I'm sorry, I missed one face here. Let me shift click to include this face. I did one undo there, and I can do. Let's see. Uh, Hold on. I think I might have. Yeah. So I would just want to make sure that yeah, I didn't select or not select something wrong. Okay, so I guess it's okay. I just wanted to. So here, by extruding the face, I can incorporate certain amount of flatness in this area, and that's what I wanted to do, right? Because I have extra vertices. So something like that, right? Yeah. So I'm pretty close to like what it was before, and obviously you can you know, do further further sculpting here. I selected these edges. You can move it down. Any kind of sculptural model building is fair game. And yeah, so you get the idea, right? So since this bottom area is it's kind of like extension of this moving joint, I'll keep some flat feeling looking and keep it like that. So at this point, I'm actually ready to do further detailing, whether it's Maya or whether it's exported to something like Solidworks or Sculptures or Top Mod, what have you, right? All those are fair game. I just want to move this out a little bit to kind of yeah, it's kind of interesting form wise. It's kind of like a maybe it's like a fish. I don't know. Something much more organic. All right. So, okay. So whatever suits you, you can do that. So what I will do is, if you want to take this form back to SolidWorks and use it, you may. I'm kind of like moving these around to give a little more volume here. Maybe that's needed for some sort of a functional reason. Maybe there's some internal mechanism that you need to house. I don't know. So let's do that. So this one, the name of this, I will name this as a, what was the name of this? KUKA Robot Arm 4. Okay, so that will be, let's see. I'm going to save the scene first, okay? So I'm going to go to the scenes, and then this is the KUKA Robot Arm 4. And I'm going to save version 001, okay? So, okay. So it's giving me, notice that this is a student version, and I say okay. And now, at this point, you need to convert the format of this, sorry about this little pop-up here. You need to convert this geometry to something other than polygon. So remember, this is the actual geometry that I have. This with the number 3 key is a preview of what it should look like if I convert this into subdivision surface. So that's what I will do. I'm going to say this is the robot arm for new A. Okay, so that's the name of this. And actually, this is the form. This is the general form, and I'm going to create a new layer and duplicate this. I'm sorry, assign it to that new layer. I created layer 1 and assigned this to that layer, as you can see, right? And then what I will do is I will duplicate this whole geometry because this, I want to leave this alone. I don't want to change this original form. I want to do Control D and then assign that to a new layer. And that way I have the original one that is still around and it's not, modified, but I have this duplicate of this that I can modify or, convert without worrying about losing the original. So let me do, 3, but the conversion that I'll be doing is the two-step conversion. You'll be going under Modify, Convert, and you'll be doing first the polygon to subdivision conversion, and then second, subdivision to NURBS conversion. So it's a two-step conversion process to go from polygons to NURBS conversion. So the subdivision surface is the bridge between the polygon geometry and NURBS geometry that makes it possible. Okay, so I will do the two-step conversion. So polygons to subdivision. Now, as a reminder, there's a limit as to how many faces you can convert. 1000 is default, but you can increase that. But usually, if it's too high poly, then you might want to decrease the polygon count before you do the conversion into a subdivision surface. So I will leave it at the default and then create. And this is the resulting subdivision surface. The name indicates it. It says polygon 2 subdivision form. And then if you press number 3, this is the proper display of what it would be if it's rendered and so forth. So this is the subdivision surface, and so with subdivision surface you have like a really nice opportunity. You can select any face. Let's say you want some sort of a detail here. Like you can say face, and then you can select. Hold on. Oh, so can I do face selection? For some reason, let's see, display level, display, or how about vertex? Sub D, yeah. So I'll get into more subdivision surface modeling in just a second. So let's not get into that right now. But here, let me do the second step conversion, okay? So modify, convert, subdivision to NURBS is what you want to do. And when you do that, you will notice that the shading turns funny. Green, it doesn't look like it's three-dimensional. And the reason for that is because mathematics for the shading algorithm is totally different for the NURBS surface. Because you will notice that if you select one surface and move it, it has been taken apart. Now, without the shading in place, you can barely see the form. So let me right mouse click and assign new material to these surfaces. So let me do Arnold standard surface, and you can see that it's a white color surface. And now you can see more clearly that these surfaces have it is a minimum of 6 faces because it started with a cube, right? So a cube had 6 faces, so it was very natural for Maya to separate this into 6 different four-sided NURBS surfaces. So here I just wanted to illustrate that. So yeah, let me do undo Z Z Z Z Z Z to put this back to the assembled state. So now what you will be doing is you will be selecting all of these surfaces. You can either select them like this, which will select each individual one at the lower level like this, or you can select the whole group like this. It really actually doesn't matter. It doesn't matter. But what I will do is I will select this name, and I will select this name and then erase it, and then duplicate this, Control V, and then say this is the NURBS to indicate that these are NURBS surfaces for export purposes, okay? So that's what I will do. I will double click and Control C to copy this name, and I will do the export selection command. I will go to the options and select IGES export, which was the previous setting that I used, and then do the export selection. And here I will venture into my OBJ IGES FBX top mod folder, and I will paste the name. So KUKA Robot Arm 4 new A NURBS is I will export. And as a safety, I will also save the scene, the Maya scene file. So robot arm for C general, no, that's not what I want to do. So robot arm version, yeah, KUKA robot arm for version 002, 001. I'll do version 002 because I made some progress on it. And at this point, if you examine in your folder, you should have the IGES file, the KUKA robot arm for new A nerves IGES file. So this is possible to import this into Solidworks. So that's what I will do. So in Solidworks, let's go back to Solidworks, and I will be updating the part file, which is Windows KUKA robot arm for old. So this is no longer a old design. So what I will do is this. I will resave this as a new save as and rechange the name. So I will say save as copy and open. Okay? And I'm going to rename this as not new but new. And it turns out that I may have KUKA robot arm for new SolidWorks file. Do I have? Maybe. So copy, save as copy, and open. Save. Oh, so no, I didn't have a file name like that. But yeah, so it looks like KUKA robot arm for new is my updated file. So at this point, now if you go into the assembly, I believe that this is still referencing the old file. And it's saying that, oh my gosh, I'm getting an error. And don't be don't worry or just be panic when this happens. The reason for that is because in the part file for this robot arm, the body was deleted. So naturally, of course, it's going to run an error. Say, hey, you know what? These parts, this arm and this arm is referencing part of the robot arm here that is missing. So you say, oh, no problem. You will go into the robot arm for new old, and then say, I no longer need a body delete, so I can just take this feature and just delete this, and I got this back. So now, if I go to the assembly, assembly should no longer have that problem. Okay. So this assembly still is using the old design of this arm. So what I will do is this. I will resave this assembly as a new assembly, or I could just I think that's what I'll do. Yeah, that's I'm gonna resave this assembly file. Say save as, and say KUKA robot assembly new. Okay, like that. Okay, and yeah. So if I save this, then component document must be saved. No problem. And what I can do is I could take this part and then hide this. Let's see. Well, I can just say tab. That's just a visual hiding, but that serves the purpose, serves our purpose. And I will go into the part new file, and into here, what I'll be doing is I will be importing these surfaces that I had exported from Maya. Okay. So far, how is it so far? Is it yeah? Just don't be afraid to pause me or you raise your hand and say, "I'm confused," or "Could you do it again?" or things. So once again, the importing surfaces is not under file, but it's under insert features imported. And when you choose that, you have to go into the correct folder. So let me choose this name of the folder directory, and then copy that, and then just paste that in here. And you have to choose the appropriate file type. So you have to choose IGES file type. And I just a lot of times use the date modified, so that gives me the latest one on the top. Okay, so KUKA robot arm new A nerves. So that sounds very promising. And one very important option that you have to make sure is under options, you have to enable 3D interconnect. That is checked on by default, but this will not work if you don't check this off. Okay? And then here I have the option of trying forming the solid or knitting the surface together. So I will choose knitting the surface together. Uh, you can say keep them separate and do the knitting manually afterwards. But here, I think in this case, this is fine. So I will choose the robot arm for new A nerves and say open. And that will import the surface. Okay. And I think that since the color is the same between the previous one and the imported one, that's not really helping me. So let me just choose this surface imported, left mouse button, go to the appearances, and choose the surface to have a different color. And I think the white color or gray color is probably sufficient and appropriate and sufficient for me. So at this point, what I need to do is, since this is a surface only, if you choose any of these section view, you will notice that it is hollow. It is not solid. Okay, so that if you cannot 3D print or work with this unless you make it into a solid. So what I will do is I will let's see. I think for this one. Let's see. I will probably only work with these three surfaces. I think I will do that. I will delete these surfaces. I think that's what I will do. And for this one, I will, let's see, let me do tab to hide the surface. I will probably use these surfaces and extend the edge of this surface here. Extend the edge of this surface so that it protrudes out of the form. I will not work with these surfaces. I will simply delete them. So in this case, as I selected them, I can hit the delete key, and I can say, hey, I want you to be gone. Oh, I'm sorry. It's not the surface, it's the face. Yeah, different terminology. If you say surface, it's going to delete the entire group of surfaces that are touching. So here, let me click, shift click, and then do the insert. Face delete let's see, I'm sorry, under face delete, yes, sorry about that, face delete, and say these three surfaces. Option is delete, not delete and patch. I'm just gonna say delete, and that's it. So this lets me delete those surfaces, and I will do something similar with this one. I will choose to delete these faces here, insert, face, delete, and delete without patching. So I have that. And now if I do shift tab to bring back the visibility of the imported surfaces, I have like very barely intersecting thing. So what I will do is I will extend the edge of the green surface here to have a very sure, definite intersection. And for here, I will probably do the extend. Oh yeah, it's not even touching, so I will definitely have to extend the edge of this surface so that it will go through into the body of these surfaces here. So it's a edge extend function that I will use, and I think that I will do the tab again to invisible these. So for this one, I will extend the edge of this edge this way. So that will be insert surface extend. Extend is here, extend, and that will be a distance. You can specify which edge to extend here, and that's a pretty significant amount of extend. You don't need to do that much. You can do like maybe half of it, but yeah. So that's exactly what you need to do. So there's an extension. If I do shift tab to visible the surface, I have a very clear, definite intersection here. So that's no problem. Let me do the extension of this surface edge here. So I will repeat the command of extend, insert surface extend, and it will be this edge here, this one. And this one is a 5 centimeters. Maybe I will keep it 5 centimeters. To be safe, I'll just do 8. So if the shape of these surfaces are very organic and like going like all over the place, compound surface, then these kind of extensions could run into some problems over if you do it for a long distance. But For these like very linear kind of extension, no problem. So long extensions are not a problem. So Shift Tab to bring up the back the display, and if you want to examine the inside, um, you can take them off display, so you can see that there's an indication of the surface going through the body, or you can also do the section view. This is the section view cross cut view, and this one I just need to select the appropriate direction, one of these here, and then if you drag the arrow around, you can see that there's a very clear intersection of surfaces on the inside of the form. Okay, so I think I have sufficient amount of information to do the intersection and trimming, so I can escape to get out of the section view. And at this point, I will save this part file. So Kuka robot arm for new. So that is the perfect name. I think that is fine for me to use. I think that the location of the folder is not correct. So let me go to this one. I'm saving all the other CAD files in this same folder. So let me for new. Yeah, so Kuka robot arm for new. Okay, so I have that. Do I have the assembly in the same location? I hope I do. If I'm not, I'll find out and I'll fix it later. So let me do the trimming. So I can do, actually, you know what? Yeah, let me do the trimming first. Okay, so insert surface, trim, and you can say mutual, and I will do this part first. I'm trimming these surfaces against these, and then you can say keep or remove, and it's easier for me to click on the parts that I want to keep. So I will say keep selections, and I want to keep the large part here, and I want to keep this part. Oh, you know what? It's doing the opposite of what I wanted to. What's going on? So can I do remove? Oh, geez. All right. Well, let's delete this, remove. So can I do this? Well, that's also removing it again. How strange. Wow, so keep and remove is doing the same thing? That's funny. I don't want to do that. Okay, so I will do then remove selections. And in order to select, can I get inside the form? In Maya, you can go inside the form to make selections, but Solidworks 3D camera works very differently. It won't let you go inside the form no matter how you get close. So you have to make use of the right mouse click. So I don't want to delete this visible outside surface. I want to click and choose the part of the surface that is inside, but not from the large surface here, but from the small surface. So you have to right mouse click and say select other, and then now I have the second choice, not the first choice, but second choice, which is the inside of the cylindrical part. So that is the portion of the surface that is selected, that is going to be wow, clear selection. Let's see, you just have to do like select other and then choose inside. Oh, come on. I keep on selecting the wrong one. Okay, so remove selection, right mouse, um, select other, and it's the second one. And oh man, I'm sorry. Yeah, it's just giving me like this kind of like funny thing. It could be that let's see, and then I want to choose. It's not even letting me select any portion of the. Yeah, it basically selected. Keep selection. Can I choose this? Oh, that's deleting that too. Oh, geez. Come on. That's not fair. So basically, it's not really behaving the way it should be doing. But yeah, I'm sorry that you don't want to be facing this situation. I can deal with it, but I can imagine you having a hard time. So let's see. Remove selection. Can I remove this part? Okay, so that makes sense. So can I delete this one? Okay, so let's see. Oh, come on. Okay, so remove. So can I, gee, it deleted the whole thing, huh? So can I do right mouse click and select other? So no, that's not what I wanted to do. Yeah, sorry that this is like, I didn't anticipate this much trouble just selecting surfaces. It's not normal, let's put it that way. Actually, you know what? I have a feeling I might be, it might be the case that this inside circular surface might be touching that surface. I don't know. Let me just examine with the section view. Sorry about the, once again, sorry about the confusion. Yeah, let me examine what is the case. Is that touching? No, there's plenty of distance here. So, okay. So I just wanted to make sure. Um, you can do, okay, so let's work with the front part first. Let me see if I have better luck here. Trim, yeah. This is actually a pretty easy step. So so I'm going to select this one and this one and remove selection. Yeah, remove should work. So I'm going to remove inside of the circular area first from the large surface. So that's good. All right, and I'm going to remove this overhanging surface. And that's the way it should be working, right? So yeah, I mean see how easy that was, right? But this part was giving me a hard time. So let me I have an idea. Maybe I can activate the section view, okay? So maybe I can use the section view tool to display this part, right? And if I keep the section view like this, right? Maybe I can click on this. I bet you I could. All right. So let me do insert surface trim, and then say mutual trim, and I will select the large surface and also the small surface here. So these, right? And then I will say remove. Oh wow, it's giving me like a, huh. It took away the section view. So it wasn't letting me select. Oh wow. So apparently it kind of like turns off the section view. Yeah. So that's So what can I do here? Well, I have an idea. Yeah. Okay. So this one I will do a little bit. So let me turn off the section view. Uh, I get to show you a little bit more functionality, no problem. So you understand that this is a surface here, right? Because you have surface body, we have two of them. We have this surface here, and then you have these surfaces that are just one. What I will do is I will turn this bulk, this fish singular shape, including this detail, into a solid. Okay. So let me do boss, thicken. This is a necessary thing that you need to know anyways. So here, if I select this, I can either thicken by a wall thickness by number, or since this is a closed volume, I can say create solid volume from create solid from enclosed volume. That's the option that's available if the combination of surfaces closes up a watertight volume. Then I have this available, and that's what I want to do. So now this is not just surface; it's a solid. So if this is a solid, you can see that this is a solid, and the section view is it colors in, right? So the top is still surface, so it's empty, but the bottom here is solid, so it colors in the face. Okay. So now what I want to do is this. I want to add this as a solid. So that's good. All you need to do is this. I'm gonna create a closed volume out of combination of surfaces, these surfaces here. Okay, so I have a surface here, and I also have a surface here, right? So these surfaces combined can make a closed volume that defines the inside of this shape. I hope that makes sense for you. I'm sorry if you don't understand it right now, but let me illustrate by doing it. Okay, so since this is a solid, I'm going to duplicate this particular surface that intersects this shape clearly. So I will do insert surface offset. And offset is by 0 amount. Okay, so that's how you duplicate the surface exact shape, exact same place. So I have this surface here, and for the illustration purposes, I'm going to take the solid body here and then color it different color so that you can see it differently. Okay, so the body is a different color, and I guess this gray color is fine. So you can see that the body is gray color, and then on top of that you have this one face that is overlapping green color because that's a duplicated surface off of the solid. And I will use the tab key to hide the solid. So you can see that now I can work with these combination of surfaces to create a closed volume that defines this area here, this shape area that includes the organic compound curve of the bottom, that goes along the body of this here. So here, I bet you, let me actually save this before I crash. So for new, I'm going to just overwrite the previous one. So now I will do surface trim, and this trim is a mutual trim. I will trim this against this, and then the remove selection. I will remove this large area, and I will remove this overhanging area in the bottom. And the result is the combined set of surfaces that are like this, okay? So now this is a little bit easier for you to digest. If I do the section view, you will see that this is still a empty surface. You can see that it's not solid, okay? And now I can say, all right, I want to make this solid. So you can say insert features, boss thicken. And you can say this surface here. And since these surfaces close up a watertight volume, you have the option available to create a solid from enclosed volume. And then sometimes merge result is turned on, but that means that anything this is touching, it will be merged too. In this case, maybe you want it, but I want to turn this off just to show you that it's better to have it turned off. You don't want to blindly merge this with any invisible volume that this volume is touching, okay? So here I'm going to create a solid from the enclosed body of surfaces. And here I have two solid bodies. I have the previous one here, and I have this new one, the disc shape. So it's two separate solid bodies, and you can verify that by doing section view. And here it is, right? So you have face shading on what is solid. So it is a solid, okay? I'm going to do escape again. And at this point, I will do the insert features combine. Combine. So this combine command is any touching or interpenetrating solid bodies can be combined. So since these are touching with a common face, they can be combined. So this will be operation type, bodies to combine, this body and this body, and that's it. So I just combine this into common solid. Okay? And here, if this is a single solid, you can, let's verify that by doing section view. Section view gives me like a beautiful section view of the solid, right? Let me do escape to get out of it. I suggest that you do things like something like a fillet. Fillet is here, and this is a pretty large fillet size, so maybe I start with a small one, 0.1 centimeter. I believe that this model is not to scale, so let me choose this edge here. So fillet for preview, 0.1 centimeter radius, something like that. Oh, that's a very small radius, so I think maybe 1 centimeter was appropriate. I was being very safe. And maybe even bigger, 2 centimeters, or yes, or 3 centimeters. Yeah. So eventually this fillet is going to hit this edge. A lot of times it's not a good idea for the fillet to hit the edge because you get some messy surface and all that. So let's be a little bit less, 0.75. Okay, well actually, you know what? I think I typed in something very unreasonable. I think 1 centimeter was okay, but I think 3, or maybe I'll go back to 2 centimeters. Okay, So I think this 2 centimeter is reasonable. And when I complete that, I have a nice fillet detail here. And if you're very meticulous, people enjoy doing, like meticulous people who do the lots of high quality work, they love to fillet everything. So, for rendering purposes, if you're doing a nice rendering, even though it might not be mechanically necessary, sometimes it's nice to have fillets for rendering purposes. So for me, yes, it worked out very nicely and over the years. So I suggest you to, for rendering purposes, do some filleting for prominent edges. So I think that 0.5 centimeter, maybe two, I don't know, is that too much? Or for some reason, it's not giving me, let's see, let me do clear selection and let me select a different edge. For preview, tangent propagation, no. Yeah, for some reason I'm having hard time. Oh, you know what? It might be because this is like where the different faces of the surfaces are like there. Yeah, so maybe I'll have better time if I do face. I'm sorry. I meant to do escape out of this. So okay, let's forget the fillet though for that one. I was trying to get fancy. So now I have this arm built. Let me save this, and I'll show you how to assemble it into the assembly. So for this assembly, since this part file is open already, let me do a tile. I'm going to simply drag this part file. In this case, you can just drag the part into the space like this because you have to position it anyways. So that is appropriate and perfectly fine for you to do that. And this arm came in, and the default is that you can grab this and move it around. But to rotate, you have to choose the rotate command, which is, I believe, the let's see, I believe move, and move is the default, and but here, I think I can choose rotate. So if you click on this little tab here, instead of move, you have rotate component. So now I should be able to rotate this to a certain angle. So you have to kind of like do this like it's you have to get used to this motion. If you're not used to this motion, if you might find it kind of funny, but you get used to it. You have So here I think this is kind of ready for it to for me to start creating the mates. So I say rotation is sufficient, and I will create the mate, and then say I will first create the concentric mate. So I will mate this inner cylinder wall against this outer cylinder here. Okay, so I'll click this wall. So that moves the arm into a position so that the cylinder axis is aligned. So I will complete that particular mate, and then I will continue mating this face. Click. I want to click. Yes, and then this face. So the mating of the two faces have been completed. I will complete that mate, and I will complete the overall mating. So you have to click twice, basically. Okay. So if I test the motion, this arms motion is going like this, and so I will also continue mating these. So once again, repeat the same process, mating I think I pre-selected the space by accident, so I will clear the selection, and I will choose the cylinder against the cylinder concentric mating, and I will complete that. And I wonder if I can drag this away. Oh, you know what? This was constrained to the old version of this arm that is invisible, right? And so that arm is, you can see it in here. This is the only one that is wireframe display. So that is the arm. So if I make this visible, like Shift Tab, that is still there. And this particular part here is constrained to that arm, right? So you can either go into that arm and then suppress the mates here. Suppress is basically turning off, right? Like this, suppress, or you can just delete the part because maybe you don't need it in the assembly. I suppressed it in this particular case, so that means that this part can be freely moved around. Okay. So remember, I had already produced the concentric mate, right? I produced the concentric make between this part and this, this face and this face. So that's why it's kind of partially following the movement of this piece. I didn't produce the face mate just yet, but I will just do that now. Okay? So please don't be confused about what's going on. It's like, why is it jerky? Why is it moving funny? Well, that's because I did not complete the entire combination of mates. So this time I will complete the mating of this face here and this face down here. So that will move it into place, and I will complete the mating operation. And now I have, let's see, let me put away this arm here. I will do tab to invisible this, I'm sorry, I mean in this mating operation. Let me get out of that by completing it. Let me do tab to hide this. And now what I have done is I have successfully, this is a space bar. If you press the space bar, you can click on any of these faces to align the view perpendicular to that chosen view. So now I have a robot arm assembly that uses my new design of this arm that is much more streamlined. Okay? And it is assembled into this here. And then I will save this as a last step. Okay? So that, let's see, I'm going to now say, oh, exactly almost 1 hour and 1 minute. How amazing. So, so I will stop this.